All right. Okay, so as you can see, we're still working in lines, okay? You know, if you remember last time, what we saw was, let me get to that, here it is. Last time we actually saw what the slope of a non-vertical line is, you know, by definition. Okay, remember the slope of a non-vertical line, you know, the definition's on there. Yes, I'm recording. The slope of a non-vertical line is posted. You know, it's on the slide, excuse me. Okay, basically, again, if you have two different points on the line, different in the very least with their x coordinates, so the x coordinates are not the same, as you can see. The slope is change in y over the corresponding change in x. You know, as I said last time, I know there was something called rise over run, and I don't remember exactly what that is, but what I like to do is I like to think of it this way. You want the x and y coordinate of the same point on top of each other. Same, okay, so the x and y coordinates of the same point on top of each other. Okay, that's what we want. Okay, I mean, later on, I'll point this out as well. It turns out that if you increase your x coordinates, okay, and your y coordinates also increase, the slope has to be positive. Basically, let me say it this way. You can actually know ahead of time if the slope has to be a positive or a negative number. And if you mix up the top or the bottom, you know, you're subtracting the wrong order, your answer will be negative. True answer. The right answer, I mean. Okay, but again, there are ways to tell if the slope is positive or negative before you even do a calculation. So we'll see that later on. Okay, that was some examples we did. So we have these examples here. Okay, so what I want to do first is basically start out with doing some of these examples. Okay, so actually, I was going to have you guys calculate this. So, well, you know what? Real quickly, take like 2-3 minutes. Actually, no, take like 2-3 minutes to calculate the slope of these. Okay, so, no, actually, you know what? Let's just do it together. Sorry. Okay. All right, so basically, if we're going to get the slope of these, right, we have 1, -4, and 5, -2, okay? We want the slope of a line that goes through these points. We did an example like this last time, okay? So here, again, it's change in y over the corresponding change in x. So I'm doing -4 minus -2 over 1 minus 5. So we have -4 minus -2 over 1 minus 5. But notice also what I'm saying is that your coordinates for the same point, right, they're on top of each other, as you can see, right? For 1, -4. For the other point, 5, -2, same idea. 5 and -2 are on top of each other. And so if you do this calculation, we have -4 plus 2 over 1 minus 5. So that's -2 over -4, which is a half. Also, we have these 2 points. So this is just another example I'm doing, okay? These 2 points here, right, 3, 0, and 0, 3. So same idea, right? Same idea. Namely, we have change in y over change in x, so we have 3 minus 0 over 0 minus 3. 3 minus 0 over 0 minus 3, right? So 3, 0, they come from the same point. 0, 3 come from the same point as well. And we end up with 3 over -3, which is -1. Okay? So that's what happens here. Okay. So again, let me say that again. 3, 0, 0, 3, right? from the same point, coordinates for the same point, okay? Good, right, 0, 3. So we subtract, and we get -1. And this is what I was saying before. Notice that x is increasing from 1 to 5, okay? As that happens, these y coordinates go from -4 to -2, right? So if x goes from 1 to 5, from the points looking at this, we see that the y coordinate goes from -4 to -2. So in other words, if x is increasing, right, y has to be increasing as well. Higher x, in other words, a bigger x coordinate gives us a bigger y coordinate. That's how we know the slope has to be positive, which we found. Okay, same over here, if we increase, x here is actually decreasing, from 3 to 0. But notice the y values increase. So in other words, if the x coordinates are decreasing, but the y coordinates are increasing. So in a sense, they're going in, one's increasing, one's decreasing. That's why the slope has to be negative. Okay? That's why the slope has to be negative. Well, if you want, you can think of it this way. Here, this x is 0, this x is 3. Okay? So if we were to increase x, the y's are decreasing. The y's are decreasing. So a bigger x coordinate gives us a smaller y coordinate. That's why the slope has to be negative. Now, I hope that makes sense, what I'm trying to say. Let's do another example. So here, this one's a little bit different, okay? Basically here, I give you the line, although I did label the points, and I'm asking you to find the slope of this line. Okay? And again, really what we need are any two different points on the line. I mean, I did label the points, so it's not that bad. It's pretty easy to see what points we could use. Of course, really, you can use any 2 points on the line you want. Although here it might be kind of tricky for us to see what this point actually is. You would have to estimate. I mean, that's not terrible to do, but we have these points, so let's just use these. But notice also that the line is rising. Namely, as we move to the right, we can see our line is rising. I mean, we'll see this more later, but that's how we know the slope has to be positive. Basically, the line is going up as you move to the right. So at the very least, we may not know what the slope is exactly, but we know it has to be positive. Okay, so let's do that. There we go. Okay, so again, the points I chose are the labeled points here. Okay. Okay, so again, let's do it. We have -1 minus 4, right, over -3 minus 3. Again, you could think of it as the x and y coordinates for the same point on top of each other, and the x and y coordinates for the same point, they're on top of each other. So we subtract. We have -5 on top, -6 on the bottom, which is 5 over 6, positive. Great. Okay. So I really, really hope that makes sense. I think the next slide might help make it more concrete what I'm trying to say, but about the slope being positive or negative. But these are just some examples to help us remember what we did last time. So let's move on to this slide. So here we have 2 different lines, a blue and a green line. They both go through the point 1, 2. That's the point down here. The green line goes through the point 2, 4. Okay. The blue line goes through the point 2, 6. And we're calculating the slope of each of the two lines. We're calculating the slopes. Okay. So for the green line, right, it's going through 1, 2, and 2, 4. That's what we have here. Okay. And we can see that, you know, again, it's just changing y over changing x, right? Or over corresponding change in x. So we have 4 minus 2 over 2 minus 1, okay? So we have 4 minus 2 over 2 minus 1. Again, 4 and 2 come from the same point. They're on top of each other. You don't want to separate them, so to say. 2 and 1 come from the same point as well, as you can see. Okay. So we subtract. We have 2 over 1, which is 2. For the blue line, you know, it's a little bit, it's similar. Of course, that's what here, right? So that line is going through the points 1, 2, and 2, 6. You know, it's graphed here. So it's the same idea. I mean, essentially, in this calculation, you're replacing 4 with 6. So we have 6 minus 2 over 2 minus 1, right? As you can see, 6 and 2 come from the same point. They're on top of each other. Okay? 2 and 1 from the same point. They're also on top of each other, as you can see. And we can see that we get 4 over 1, which is 4. And here, again, I'll write this down in a later slide, but I just want to point out, though, that notice both of these lines have positive slope. And if you increase x, meaning you're walking along, if you will, on the x-axis to the right, towards increasing numbers, you can see that the lines, if you're looking upward, the lines are rising. You know, they're moving up through this part of the Cartesian plane. So as you're walking towards the right, you can see the height of the lines, right? If you look up, they're increasing. They're going up. That's how you know the lines have to have positive slope. And that's what I was trying to say before. So we know, looking at the graphs, that both lines have to have a positive slope. So if we somehow made a mistake and subtracted in the wrong order, so to say, and got a negative, then we know we did something. You know, in other words, if you increase your x, your y values are going to increase. And that's what's happening here, right? If we start at 1 and we end at 2, so the x coordinates are increasing, the y values also get bigger. So if we let x get bigger, these 2 points are on the line, the y values have to get bigger as well. That's how we know the lines have positive slope. Okay? And let me say this also. Actually, you know what? Let me stop recording because we're getting close to the 15-minute mark. Okay. Okay.